Thank you all for attending the 10 a.m. session today. As always, appreciate our sponsors for the SHRUG workshop. Our next presentation is session 4, processing the 2019 Florida Peninsular LiDAR data in Flagler County for public dissemination. Our speaker today is Matt Adams. Let's see. And Matt currently works as the GIS developer and UAS coordinator for Flagler County, Florida. He has a bachelor's degree in meteorology with minors in GIS and emergency management from Embry-Riddle Aeronautical University. He's been with the county since November of 2018 in various roles within the GIS department and has been a key contributor to the implementation of the county's SUAS program. He is currently pursuing a Master of Science degree in Geographic Information Systems Technology at the University of Arizona. So without further ado, Matt, I'm going to make you the presenter.
Awesome, thank you for the introduction there.
And just a quick reminder, everybody, I believe this is being recorded, so just throwing that caveat out there as well.
Okay, can everyone see my screen? I believe we should. So this project, we've been talking about the statewide LiDAR project for, I feel like, almost 3 years now, since I started working at the county. And now we are finally starting to get these deliverables back, which we've been waiting for a long time. We've been having a lot of requests come into our department, wondering how can we get this data? How can we download this so that we can use it, especially our engineers and other contractors throughout the county. So per Jason Ray, who is the project lead, everything has now been, or is on track to be delivered by 2021, which it's not fully posted by the USGS yet. There's a lot of counties that still quite don't have their deliverables, but overall the project is at about 90%. So this is the dashboard that shows you where everything has been completed. As you can see, Flagler County has been made available to download. That big white section within our county is the city of Palm Coast, who paid extra to receive their data prior to the actual distribution. So we have access to that data through them, but we do not have that data directly in-house here at Flagler County. So the main point of this presentation is to kind of go over how we decided to disseminate this data and process this data. We had over 300 individual tiles of data that we needed to process. And also we had to reach out to Volusia County, the city of Palm Coast, and eventually we will be getting data from St. Johns County to make our data set complete. So the steps that we went through, and we're kind of going to go over each and every little section here. There's a lot to talk about as it comes to the code and setting up Amazon Web Services. So I might move kind of quick, and then if we have some time at the end, I'll take some questions and we can dive a little bit deeper. But we're going to go over how we obtain the data, how the scripts work to both process the data and then package everything into an individual zip file for each tile, how to generate the map of tiles and export it as a PDF, store those in Amazon Web Services, and then generate a PDF with the links to download those tiles. So first off here, we've got the ways to obtain the data. So this link is not quite working here. But if we go back up here to this experience, I will take you guys out to this other page so that you can see where the data can be downloaded from. This story map did not want to embed that PDF as nicely as I would hope. View by set. So this dashboard here in Experience is created by the FDEM. So this is all done by them. They created this PDF that explains how to download the data in bulk. It's a very large data set. It's about 141 gigabytes. So we ended up needing to reach out to our IT department for them to download our data here. As you can see, these are the counties that have the LiDAR point cloud available already, Flagler County being one of them. So we had our IT department work through getting all of those data sets downloaded into a file location that we could have access to. Once we had that data, we realized that it was just the raw LAZ files. So we needed to convert the LAZ files to an LAS format, then create a LAS data set for each of those tiles, and then finally create the DEM and then create contours as well. So in this first block of code, we created our imports, we set our environments, created a log file. We wanted to add a log file to this so that if the script happened to fail overnight while we were running it, we would know what tile it left off at, and we didn't have to reprocess all of that data again. At the bottom here, we generate a list of LAS files that will end up being all of the files that we will iterate through in the loop that we're about to set up in the next block of code. So here is our loop that loops through all of the files. This first if statement checks to make sure that it is the proper file. If it's not an LAS file, the code is just going to go ahead and skip on to the next one. It'll add a line to the log that prints the name of the LAS file that's about to be converted. And then this next block of code converts from the LAZ to the LAS. We had no issues running this within the code because we did have to add that a little bit later on, but it ended up running just fine when we ran that. And so as you can see here, it takes the in LAZ file, puts it into the target folder. We run convert LAS from the conversion toolbox, and then it'll print those messages and add them to the log file again, just to make sure that we know where something failed if we ended up running into an issue. The next section, and this is all still within that initial for loop that we set up, it is going to take the out path, which is going to be all of the DEMs. We are also going to set some other parameters like the counter, which is going to end up being the tile number. So whenever we created that PDF at the end, there's a tile number for each and every single tile that we were generating. And so that would then give us our out path by concatenating the out path and then the out name, and then also the value field. So we wanted the elevation in this DEM that we create, so we went ahead with that. This next little block from lines 43 to 45 is going to remove that LAS file extension and then, or LAZ file extension, and then add the LAS file extension to the file name, which can then be used to create the full path of the LAS data set within that next section of code. This next block actually is where the conversion takes place. So this is going to create an LAS data set from the LAS file, again, print the messages and add them to the log file. And then same thing for making an LAS data set layer. In our initial creation of this code, we did not have this block of code from 57 to 60 because we didn't realize that it was not returning only the ground returns. So we wanted to change that to the class code equals 2 to give only the ground returns. So this eliminated a lot of noise, made our contours a lot smoother, and made it overall a lot more usable, because before we were just getting a giant blob of contours at the end, and it was truly unusable for any of our users. This next block of code takes the LAS data set to the raster and creates the DEM based on that other LAS data set with all of the ground points only. So it creates that new bare earth DEM that we will then use to create the contours. We initially, again, did not have this smooth or focal statistics block in there as well. We noticed that it was still not quite as smooth when the contours were output as we would like. So we went ahead and added the focal statistics. It really smoothed out the contours, made them a lot more usable in the long run. And then finally, we generate those contours using the Generate Contours tool. Again, after we set up our initial variables, we made our contours at a 1 foot interval. In Flagler County, we don't have very much elevation change, so this was a good enough interval for us. If you wanted to change that interval, you would just add a different number there instead of that 1. And then we, again, ran the contours tool, got all the messages, printed them, and then added them to our log file. Is there any questions so far on that section of the code? I believe there's a chat box in here if anyone has anything so far. Okay.
Hey, Matt,
So
no questions yet, but great stopping. Yep. So next section, I'll be sure to let you know if there's any questions that arise.
Awesome. So then once we had all of these data sets, they input into individual folders per the way we wrote that code. So we wanted to write another bit of code that would get all of those files for each individual tile into one singular folder and then zip it up. So that's what this next script does. And unlike the other one, which we ran that entire script, just everything at once, and it zipped everything, and it processed everything exactly how we wanted. This one we ran in kind of individual blocks. So I'm going to go over those individual blocks that we ran just in a command window, and then we can kind of go from there. So again, we did our imports, we set some initial variables. This new path is going to be the results folder that we want to put all of these items into. Again, create a list of the data sets that we initially want to loop through and set our counter to 0, which will end up being our tile number as we run through these scripts. So this initial for loop is how we get all of the LAS data set into the new folders and also generates the new folders. So it's going to loop through all of the files and then again, check that the file ends with that LAS data set file type. If it does, then we're going to move through this block of code that is going to look for the file name of Flagler _ tile number.lasd. It'll create that path. It'll create the folder name, which would end up being tile 1 in this case, since it would be the first iteration, and then it would again go on based off of that counter. And then this is the folder for where the Amazon Web Services bucket, it's just our results folder. So it's going to create a new folder for each and every one of those tiles, which we will eventually zip up once we've moved all the data into there. Again, at the end of here, we work on getting the new location made there with the new file path and file name, and then the last line of code actually moves the file from that original output location to the final folder for that tile. This next block does the same thing, except it works for the DEMs. So you see we set our initial variables at the beginning. Instead of using a for loop, we used a while loop so that we can loop through every single file in that folder. We also had to create a keyword here. So this is searching for specifically Flagler elevation and then whatever tile number that is. And then the if statement will check to make sure that if it is that file, then we will go ahead and go about moving it. If not, it's going to just continue back to the previous one. This section of code, I was unable to get it to run for all of the files at once. And so each of those DEMs had about 6 or 7 different items within the DEM. So we ran this 6 times and then all of the files were added to the correct tile folders. And so we didn't think there was anything else needed to end up making that run automatically because it's not that big of a deal to just run that one after another. The runtime was very short. It was only about 2 minutes per run.
Matt, quick question. It's kind of appropriate, but why use LAS files? Couldn't you use compressed ZLAS files? That's a question from Jacob Colby.
I'm not quite sure. We used the LAS files just because that was what we were given. I'm sure you might just have to modify the code a little bit to get it to work with the other ones. But we wanted to just use the LAS and then be able to convert them to the LAS data set a little bit easier. We had the LAZ files in that initial section and we converted them to the LAS. So I would assume so. We've not done that here at Flagler.
Great, thanks.
So then once you've got all of your DEM files moved into those folders, you will then go about moving the contours, which is, again, running something very similar to that previous block of code. So it's going to set the counter back to 0, check for the contour path, the new path, which is going to eventually be each of those tile folders, and then create a list of all of the contours. Then you're going to loop through all of the contours in that while loop, again, searching for the keyword, moving them over. If not, it just moves on to the next one. I can find the example of how this data comes through to us, because it ended up being a lot of data. So when we move and run all of these scripts, so each of these tiles comes through with that whole contours shapefile, the elevation shapefile, and the LAS dataset file. The final little block of code that we have, this one, I found this function online to end up wrapping up everything into that zip file. So basically you set the path to the folders, which is going to be that results folder with all of the tiles in it. Then you're going to use the zip file to create a new zip file and open it in a writing mode. Look through all of those folders, all of those files in the folder, and then add them to that new zip file, is basically what that function does. This last block of code is going to loop through all of those files and then zip every single one of them up into that individual zip file, which then at that point, you're ready to move on to the Amazon Web Services side of things and getting that set up. Any other questions so far before we dive into Amazon Web Services?
Not yet.
Okay. So tackling the part of actually processing the data was only one part of our challenge, and then getting the data out to the public was a whole nother. We don't have anything set up at Flagler to share data with the public. I mean, we have an FTP site, but that's a little bit difficult and the public doesn't hit that as much. We've got it password protected and whatnot. So we were looking for different options, and it turned out that this Amazon Simple Storage Solution, or S3, was going to be the best option to meet our needs. It's very low cost. In fact, we pay nothing every month to store and host all of this data. Larger data sets you would likely have to pay, but it is very inexpensive. I mean, I'm talking 19 cents per 100 gigabytes or something like that. So it's very affordable, which as county government, that's definitely a plus for us. So here in Amazon Web Services, this is what the S3 page looks like. You're going to want to go to Create Bucket to start creating your bucket there. In the public access, you're going to want to turn off all of the block public access because you want the public to be able to reach these data sets. So as you're creating it, you want to make sure you uncheck block public access, and then again, the public will be able to see it. You'll still need to update the bucket policy, which is kind of the whole security policy. And this was kind of tricky for me at first. I had no background with Amazon Web Services prior to getting this whole system set up. But so when you go to edit your bucket policy, it's going to give you this JSON here. Using the bucket policy generator, which is right here, you can end up changing that policy to allow get objects, which is the specific action that allows the users to download your objects within that Amazon bucket. So here is what the Amazon policy generator looks like. So you'll change this first drop down to an Amazon S3 bucket. You're going to want the effect to be allow. The principal, we're going to just use the asterisk wildcard, which means that all files within that Amazon bucket are allowed to be downloaded. And in the actions, there's quite a few different actions that you can choose here. For this one, we only allowed the get object, which again is what lets you download those files. And then this Amazon resource number or name is coming directly from your Amazon bucket properties. So if you go to the properties right here, it will show you that Amazon resource name, and you can put that in there and then click add statement. This tool will automatically generate this JSON here, and then you can click save, and then all of your bucket items will be updated. Once you have the policy updated, then you can work on uploading your data. So this is what the Amazon S3 bucket homepage looks like. If you click on objects, then you can click upload. It'll bring you to a folder that will then allow you to navigate to a full folder. You can select the folder of all of those results features, which would be all of those zip files that you created via the Python script. Click upload, it'll load them all in. Again, in the permissions dropdown, you're going to want to change the predefined ACLs to grant public read access so that the public is able to see those data sets, and then click upload. It won't take too long to upload depending on how many tiles, how much data. It took under an hour both times I uploaded it, and I was uploading almost 400 different tiles. So this is just an image of what our finalized PDF looks like. Again, on the actual PDF, every individual tile here is clickable. It allows you to download. What we had to do was create a mosaic data set from the DEMs, which gave us these footprints of every one of our tiles. We then ended up using calculate field to only display the tile number, because each of those tiles initially was called Flagler _ elevation _ tile number. So we took just the tile number and made that in its own field, which we then used to label this document, exported that PDF, and then got it to the full layout that we wanted, exported it, and then opened it into Adobe so that we can add all of our individual links in for every one of those tiles. So here within the PDF editor, you can see every individual box that we had created for the individual hyperlinks of every single one. So when you draw your individual box for the hyperlink, you can then paste the URL, which you can see right here is the object URL. This will be the same for every single tile with the exception of the tile number. So if you just copy that once, you can input the new tile number every time you paste it as you are drawing those boxes in on the PDF. We changed the appearance to an invisible box so that the user was only seeing those individual tiles. And then once we got it done, this was the most tedious part of getting this made. But then once we clicked save, we were able to share it and go, everything worked just as we hoped. We also included a link to the City of Palm Coast's data right here, and then a link to our open data site that allows people to put in a data request if there's additional items that they would want or anything like that. So this is the actual output of the PDF. Again, you can see every one of these tiles is a hyperlink. If you click on one of them, it will start the download automatically. Each tile comes to about 2.5 megabytes. If you click here, it takes us over to the City of Palm Coast's LiDAR data information. And then again, on our data request, that's just going to take the user directly to our survey where they can request additional data and go from there. So I'm going to drop this in the chat window so that if anyone would like to look at this story map and refer back to it, I believe I can change this to everyone. It does not let me share with everyone, but we will make sure that we get that out to you so that you can go back and refer to this. And so now, does anyone have any additional questions at the end? I was a little shorter than I anticipated, but rather be short than long.
There you go. Thanks, Matt. I don't see, refresh the questions. I don't see any new questions. Anybody have any questions for Matt? I guess I don't really have a question as much as just a comment, but the Florida Peninsular LiDAR dashboard is just giving credit where credit's due, but we actually made that in-house here at DEP, and it's administered through the FGIO's office. So for any link, that's just floridagio.gov, and that's on our resources tab. So if anybody's looking for the original dashboard that Matt showed, yep, right there. So that's great that you've been able to use that. When our AGO administrator Aaron Kolker put a lot of time into that. So.
Yep, yeah, it definitely helped. We're still waiting. If you look at our data set here on our PowerPoint, the northern edge of our county, we're still waiting for St. John's to get their deliverables so that we can fill in these last few little blocks. Our data set here, you can see we've denoted PC. So those are data sets that came from the city of Palm Coast. And then again, on the southern portion of our county, we've denoted the tiles with a V at the end because those were data sets that originally came from Volusia. Just so that the user knows where the data is coming from that they're using, so that we can direct them back there if they've got any additional questions about that data set.
That's great. So Jacob's asking, can we obtain a PowerPoint presentation? And I believe this is just in story map form, right, Matt? So
yes, it's just in story map. I dropped the link in the chat, but it looks like it will only let me share to organizers and panelists. I don't know if there's a way for you to share that.
Sure, let me see if I can share that out with everybody, entire audience. How's that?
I'm working on getting the scripts added to a GitHub repository, and I will add that to the end of this story map once I get that done.
Great. I think that was part of it as well, is that that they would like to see kind of the Python scripts.
Yep, yeah, so I'll get that hopefully by the end of the day today. I'll be able to get those added there. And then if anyone has any questions, I'll be sure my contact info is on this story map as well, and you guys can reach out directly if there's anything else after this presentation's over.
Matt, just one more, and maybe just Paul might have missed the response earlier, so it was similar, but he asked, why did you use the .laz files instead of the already created 2.5 feet DEM available for download?
We just started with the LAZ files because that was what we originally had downloaded. We wanted to just kind of go through the whole process ourselves so that we can see everything along the way. And then it also gave us that original LAS data set so that we can eventually look at additional DEM returns as well. We weren't limited to just having the bare earth DEM or just having all returns. So we had now access to that LAS data set that we can then utilize for additional items.
Great. Any other questions for Matt? I don't see any, but this, like all other sessions here during Shrug, this session has been recorded and will be made available later, I believe, through the Shrug YouTube channel. I think if any additional questions come in, Matt, I'll note them down and email them to you. Just with the attendees contact information there. And otherwise, thanks so much.
Awesome. Thank you guys for attending. Again, like I said, any other questions, feel free to reach out, and then I will be adding to that story map here this afternoon.
Great. Thanks everybody for attending. Hope you enjoy the rest of the sessions today.